Hello everyone, I'm Hao Jun from University of Washington. Today I would like to give a presentation about performance comparison between different lighting datasets during CHUVA campaign. And here is my co-authors. Let's look at the outline. First part is the introduction. I will introduce the Wallen and the CHUVA region I used in my research. Second part, I will show some background results. And third part are the comparison results between Wallen and the Brazil data. I will compare the location accuracy, detection efficiency, and peak current and energy. The last part are the conclusions. Wallen is short for Worldwide Lightning Location Network. It contains 64 stations. And here is a figure to show the location of the Wallen stations around the world. And in each station, we will detect the VLF radio waves from lightning and calculate the TOGA, time of group arrival of each wave packet, and then send the time to a pair of independent processors to calculate the best fitting for lightning anywhere in the world. So, although we only have 3 receivers in Brazil, we can still detect the lightning strokes in the CHUVA region. The CHUVA region we used in our research is plotted in this figure. It's centered in Sao Paulo, 23.56 south and 46.49 west, and the radius is 666 kilometers. And we will compare the Brazil data and the Wallen results in CHUVA region from November 1st, 2011 to March 30, 2012. Let's look at the background results first. From November 1st, 2011 to March 30, 2012, Brazil data, we also call it BTLM, detected about 11.8 million strokes. And 11.2% of them is observed over ocean, and 18.5% of them is cloud-ground strokes. During the same time, Wallen detected about 0.65 million strokes, and 21% of them is observed over ocean. Because Wallen can't identify the types of strokes is cloud ground or in clouds, so the number is not applicable here. Since BTLN has detected most strokes, we set it as a reference to compare other datasets. And in our research, we use a half-degree box and a 2 millisecond time window as the matching criteria here, which means delta latitude and delta longitude should be less than half degree, and delta t should be less than 2 milliseconds. And then we can get the event strokes both detected by Wallen and BTLM, and then we can calculate the detection efficiency of Wallen, especially the detection efficiency of ocean or land strokes or the ICCG strokes. Let's look at the results. At first, I will show the location accuracy. Here are 2 figures. On the left is the latitude distribution of the difference between 2 datasets, and the right one is the longitude distribution. And from the left, we can find that the peak is around 0, and on the right, peak is around -1 kilometers. And if we look at the half peak, we can find it's about 3 or 4 kilometers. So we can say that the location accuracy of Wallen is within about 1 kilometer in median and within about 4 kilometers on average when compared to BTLM. Then let's look at the detection efficiency. Set BTLM as a reference, we calculated the detection efficiency of Wallen for total strokes, ocean strokes, land strokes, cloud-to-ground strokes, and in-cloud strokes. At first, I want to mention that the detection efficiency of cloud ground strokes is about 40.8% for volume. 14.8% for volume. It's much higher than the total detection efficiency, which is 4.4%. And that's because volume has a lower in-cloud detection efficiency. Here is about 2.1%. And why volume will have a lower detection efficiency in cloud strokes? That's because the in-cloud strokes usually have a low energy, and in a long-range detection, the signal for the low energy will be weak and it's harder for us to detect by volume. That's why volume has a much higher detection efficiency on CG strokes than IC strokes. And then we also find that the ocean detection efficiency is about 7.9%. It's about 2 times over the detection efficiency over land. That's because the attenuation of VLF signals is more on land than on the ocean. Here I showed another figure about the detection efficiency. This is the detection efficiency changed with the peak current. So X is the peak current from -100 to 100 kiloamps, and Y is detection efficiency. We can find that when the peak current is low, the detection efficiency of volume is low, and when the peak current, the magnitude of peak current is larger than 20 kiloamps, the detection efficiency is about 60%. And when the magnitude of peak current is larger than 40 kiloamps, it's about 80%. This is the background peak current detected by BTLN. So these are all BTLN events. The solid line for all the strokes, and the dashed line for CG strokes, and the dashed dot line for IC strokes. From this picture, we can also find that BTLN detects a lot of IC strokes than CG strokes. And we also can find that the negative CG stroke number is larger than the positive CG stroke. And the peak is about -4.5 kiloamps and 3.5 kiloamps. Now let's look at the volume results. Here is the data from the BTLN events detected by volume, also divided in 3 parts. Solid line for all strokes, and the dashed line for the CG stroke, and dashed dot line for the IC stroke. And we can find that volume also detects more negative than positive current strokes here, but the peak for the distribution is larger than the previous one. And the peak here is about -10 kiloamps and 6 kiloamps here. And some of you may be confused about the cutoff here. That's because of the X range. This is the full picture from -100 to 100 kiloamps. And this is the energy distribution showed by volume. These are all the BTLN events detected by volume, also divided in 3 parts. Solid line for all events, and the dashed line for CG events, and the dashed dot line for IC events. And we can find that the peak energy of CG events is higher than the IC events. Here I want to show the results of the peak energy versus peak current. Let me tell you how I make these 2 figures. At first we get the strokes both detected by volume and BTLN, and the volume can provide the energy data, and BTLN can provide the peak current data. So use all these data, we can get a fitting formula I showed here. The left one is for all the strokes, and the right one is for the only CG strokes detected by both 2 datasets. And then we change the energy of volume to a kind of peak current, list Y here, and the X is the BTLN peak current. And the red line indicates Y equal to X, which means the peak current of volume should equal to the peak current of BTLN. And we can find that from the right picture, we can find that most of the strokes are listed on the y equal to x line, which means there is a good fitting relationship between the Warren energy and the BTLN peak current. And here are the conclusions. Compared to BTLN, Warren has around 15% CG detection efficiency in CHUVA region, and then the detection efficiency of Warren is about 2 times over ocean than over land. And we calculate the location accuracy of Warren is within 4 kilometers on average. And the last, the peak energy has a nice fitting relationship with peak current in CHUVA region. So that's all. Thank you.